From last time, we were doing a problem on simple interest. So the initial amount was provided to us, which was, I believe, $5,000. And it grew to 6,100. The term over a period of 5 years. And I believe we wanted to find the rate. There were two other aspects to it. One, if you compound the interest annually, the other one continuously. But I did add a component, an additional one, side note. We computed simple interest. So if you recall, simple interest is simple. The growth is linear. The formula is easy. P times R times T, where I is the interest. Only, I should stress that fact, we simply get the interest. P is the initial amount, principal. R is the rate and T is the term. So in our case, interest would simply mean the final amount that you have after a period of 5 years, depending on the scenario. If you are dealing with a loan, then I would be interest. And if you are dealing with the deposit, then I is a future amount that's going to get added. So the approach that we had, we only have to put the final amount in terms of interest. So it's not 6,100 that would go in the equation, rather 1,100. Starting amount 5,000 times the rate times 5. We solved for rate. So 1,100 divided by 25,000. If I recall correctly, that came to 0.044. I forget, do check your notes. In percent, this would be 4.4%. So that is the simple case. I wrote a formula later for compound interest. In that case, we have A to be 1 plus R over M raised T raised M, and principal goes outside. So the initial amount is multiplied by that funky looking function. R is in fact the rate. M, the number of times interest is applied. Per term. So that matters. So in our case, the rate is annual. So the term that we have is 1 year. So 5 years in total. A in this case is not just the interest, rather it is interest plus principal. So in this case, since we are dealing with interest plus principal, the left-hand side should be 6,100. We start with 5,000. 1 plus rate is what we need to find. So R divided by the number of times you apply the rate per term. So in the question, we have 2 options or 2 parts. First one, annually. Second, continuously. So if we consider annually, what should M be? Very good. So M is 1 because we apply the rate once per year. If we could only get that lucky with credit cards, doesn't happen. So annually simply would mean M is 1. So 6,100 would equal 5,000. 1 plus R divided by 1. 5 times 1. I simply end up having 1 plus R raised 5. We want to solve for R. So 6,100 divided by 5,100. I'm dividing both sides by 5,100. So if that moves to the denominator, I will have that left-hand side. And on the right-hand side, it is just 1 plus R raised to the power of 5. Oh, sorry, it's not 5,100, it's 5,000. Which was simplified to 61 over 50. That should be 12.2. Do check my calculation. I hope you have your calculator with you. Okay, at this step, how do we solve for R? R is trapped inside that 5th power. Think of what I mentioned last time when I went over square root, cube root, 5th root, etc. So I would like to solve for R, which would simply mean I have to free 1 plus R that is trapped inside the 5th power. Thank you. I forgot to divide by 10. So how do we get to R? What should we do? Think of exponents. I'll give you a hint. Think of fractional exponents. That's my hint. So fifth root. So if we take or raise to the power of 1/5 on both sides, Corbin, do you have a question? I see your hand up. Okay, you can lower your hand. Oh, okay. Raised to the fifth power on both sides, 1.22, raised 1/5. And on this side, I'll have 1 plus r, the raised 5, the entire term, raised to the power of 1/5. I call this my squiggly. Those two would get cancelled because we are multiplying exponents. Note, an exponent of 1/5 is the same as the fifth root of something. So you are simply taking the fifth root. Right-hand side becomes 1 plus r. Left-hand side, 1.22 raised 1/5. And what do we get? You can use a calculator. 1.04 equals 1 plus r. 1.04, move the 1 to the other side, it becomes -1. So r is 0.04, which is 4%. So suppose interest is applied quarterly. What should M be? We'll start there. Very good. M would be full. Reason being, if we have one full term, we have 4 quarters. So interest would be applied here, 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 and there. So 4 times. M is full. Our equation would simply change in one place, which is right here. Instead of 1, we will put 4. So 6100 would equal to 5000 times 1 plus r divided by 4. Entire thing raised to the power. Term is 5. M is 4. Luckily, the left-hand side is not going to change. It would simply be 6100 divided by 5000. So the changes happen on the right-hand side. So 1.22 equals 1 plus r divided by 4 raised 20. Once again, we need to solve for r but R1 plus R divided by 4, the entire term is trapped inside 20, the power of 20. So we've got to somehow remove that power. So we are going to raise to the power of 1/20 on both sides. And here comes what I call my squiggly. Those two would get cancelled. Reason being 20 times 1/20, it's just 1. In this case, power of 1/20 simply would mean the 20th root. Excuse me. Right-hand sides would then become 1 plus R divided by 4. What about the left-hand side? You need a calculator for sure. I have stressed this multiple times in class. Anytime you deal with exponents, parentheses are important. My principle is whether you use whether you are using exponents or not, make sure you have parentheses, use them. So 1.22 raised to the power of 1/20. Notice I'm putting parentheses everywhere I possibly can. Enter. I get 1.00999. I'm going to round it, like Emily mentioned, to 1.01. So 1 plus R divided by 4 is approximately 1.01. R divided by 4 will then be equal to 1.01. Move 1 to the other side. We have -1. R divided by 4 is approximately 0.01. We want to solve for R, so multiply by R on both sides, goes to the other side. We are getting 0.04 yet again. 4%. The next part is where you apply the rate continuously. In other words, we are applying the rate infinitely many times, and so if you start applying start to apply the rate infinitely many times per term, then you are applying the rate continuously. But that's a problem in maths because, as I mentioned in class multiple times, infinite is something that is abstract. It is theoretical. Infinity is abstract. Easy way to remember, we live in an infinite universe. In other words, keeps on going, but no one knows where the end is. We start to explore, we get farther and farther and farther, but we just don't know where the end is. So you may think, oh, there's no way we'd be able to solve this problem. But there is a way. That boxing part is what we use thus far. And I can't write m equals infinity. I'll just say, for now, rate is applied continuously. In other words, we are applying the rate infinitely many times. So what happens in math? We have the number e. So in your calculator, if you simply go to second ln, you would get that e. Put 1. You'll see the number 2.7182. So that is the value of e. But we call it simply e because it's irrational. There are theoretical reasons. So P times e raised mt. So whatever we had inside the parentheses would simply reduce to e, provided rate is applied continuously. In other words, infinitely many times. So the expression simply reduces to a equals p times e raised mt. Sorry, made a mistake there. mt, that doesn't make any sense. RT. So you've got to apply the rate, not m. My bad, that was my mistake. So I always tell my students the easier way to remember this is to think of the deodorant PERT. So P times E raised RT. If you like the deodorant PERT. So simple expression, and A is the same, P is the same, value, excuse me, T is the same. So 6100 would equal to 5000 E times rate times 5. Divide by 5000 on both sides. And I have 1.22 on the left-hand side. Right-hand side, I have E raised 5R. something that you've got to keep in mind. I'll put this as a note. It is a mistake. Oops. It is only natural for the human brain to adhere to practice. Human beings are sort of habitual cyclic behavior kind of beings. So what we did the first time is raise it to the power of 1/5 on both sides. Then we raise it to the power of 1/20 to solve for r. And your brain might naturally go to this. Oh, I'll just raise it to the power of 1/5r on both sides. Do my usual squiggly, because 5r times 1/5r goes away, and I'll end up having 1.22 raised 1 divided by 5r equals e. I can solve easily. This is not going to work. So we're not going to find r. All I did is move r from one side to the other side in terms of the exponents. If you look at our previous cases, the moment I took 1/20, I isolated r by itself. So I got an easy expression solved for r. Prior to that, raised to the power of 1/5, easy expression, I had 1 plus r. But in our case, I just moved from one side to the other, and Coben did note that r has to stay with e, because that would form an exponential function. So do grab your calculator. So we are sort of going to do, for now, in the trial and error basis. So what do I mean by that? Instead of r, we are going to put in x because that's what the calculator uses. So e, don't forget parentheses. It even guides you to put parentheses 5 followed by x. That's what we have here. Instead of r, I'm putting x. Very similar to what we did last time. I forget the values of a we used. Might have used 4 raised x, 11 raised x. This time it is e raised 5x. Going to hit graph. Not a nice looking graph. So perhaps we could do zoom, I believe it's zoom 0. I don't like that one either. So I'm simply going to adjust the window. Let's go from -5 to +5. And up here, 0 all the way up to let's do 4. That's the picture that I get, and it seems like the curve is going up really fast. So you can zoom in further. Instead of 4, let's reduce it to, say, 1. Over here, we'll change it from -1 to 1. When you see a problem like this, when as you do your homework, start with your calculator. Put it in the calculator. That will give you an idea as to what the graph is going to look like, and then you can go over to complete the problem. Perhaps I zoomed in too much along the y-axis. I'm going to change it to 2. Good enough for now. So, the expression that I have is 1.22 equals e raised to the power of 5 times r. In other words, I would like to find a point where this function y equals 1.22. Mind you, I'm doing it in a trial and error basis for now. Things would be easier when we get to section 2.5. Back to the calculator. You can either go for the table or you can trace. So I'll start with trace. So when x is 0, y is 1. Instead of x, we have r. So I'm going to slowly move up and see where y hits 1.22. Right now, I'm at 1.376. There it is, 1.24. Are we in agreement that the y value of 1.24 is close to 1.22? It's off by a very tiny margin. So it seems like if x is 0.04255, y is 1.237. Oops. 0.04255, I believe. Yes, the corresponding y value y is nothing but e raised 5r, ends up being 1.237. So we pretty much solved for x, which is simply r. Go back to your calculator and you can actually verify if your answer is correct. If you have the right value of r, when you plug in, say, 0.043, I'll round it, it should satisfy that equation, closely satisfy that equation. They are the same. So back to the calculator. E raised 5 times 0.043. So I'm plugging in r equals 0.043 in that equation. And if I get an answer that is close to 1.22, the value of r that I computed is correct. Well, if we don't, my life would be meaningless. It will. There we go. It is 1.234. You are not getting the exact answer. Reason, we have approximated a lot. This is a trial and error based approach. But science doesn't go with significant approximations. There has to be a more accurate way of doing things. So put a star here. And side note, accurate results can be obtained in section 2.5. I'm going to pick the same example and show you how we can get the exact same answer. So, that would be a good place to stop.